Welcome to this tutorial on building a Sudoku generator console app using PHP. Sudoku is a very simple game where the main goal is to fill a 9x9 grid of numbers using only digits from 1 to 9, following three simple rules. A digit must not repeat twice in the same row, must not repeat twice in the same column, and must not repeat in the same 3x3 subgrid, which we will call block. Usually the game comes with gaps like this one that we have to fill, following the three simple rules. But the initial game starts with a pre-generated grid like this one, with already filled positions, and then the creator hides some of the positions, and the number of hidden blocks defines the difficulty of the game. For example, for an easy level, we hide only 25% of the cells. For a hard level, we can go up to 70% and some games even more. Although playing this game is fun, in this tutorial we will focus on generating pre-filled valid random grids like this one, that we can easily share with friends or kids to play, as well as learning some useful PHP and problem solving down the line. So let's get started by creating a new project. Let's cd into it, and let's make a new index.php file. Let's open the project in PHP Storm, and then let's start by writing PHP tags. In similar projects, I like to define first the API or the way I would like to use this library or class or project. So I imagine it to be something like this. We instantiate a new class of the game. Maybe then we generate a game or a table. Maybe next we can display it or render it. This looks fine to me, so let's fix one by one, starting by creating the class. Maybe the first thing that we can start with is defining some constants that we will use down the line, like the block size that will determine the size of the subgrid that usually can vary to create different levels of the game, like a 2x2 grid for a version for kids, for example, or more. In this case, let's start by 3. Let's increase the level of the language, so we get rid of the error. The next thing that we might need is the size of the grid itself, of the table, which is usually the block size squared. Next, we can define the array that will hold the value of the grid. After defining the grid, we will need to initialize it. We need to fill each cell with the default value that will represent the empty state. In this case, we will use 0. Maybe this function, let's call it init. So let's start by creating a loop that will loop through each row, and for each row it will loop for each column. Something like this. Not the block size. We need the size instead. So this one will loop through each row, and we need another one to loop through each column, using the size as well. So next we need to set the grid of the current cell to 0, like this one. Maybe it will be useful for us to return the current object of the game. This will be useful for us if we want to change some logic. Next, when we initialize this object, we will need to call the init method, so we will always start with an empty grid or a correctly initialized grid. Let's create a constructor. and call then the init method. Next, before generating the grid, we will try to display it first so we can see the results as we go. For this, we'll need to create a new method or function. As we did here, we call it display, or let's call it render. The render function should be simple. We will start by printing a new line, and then we will do the same as we did when we were initializing the grid, empty values, but instead of initializing this time, we will try to display instead. So the autocomplete for PHP Storm is doing great in this case. Printf. So we will try to print the value of the current element of the grid, like this. Cool. Next, we might do the same as we did for the init method, which is to return the current object or instance of the game. Like this. It's format. Now, after we initialize the game, we will just comment the generate function since we don't have it yet, and we will try to call the game, and we should see the render function. So here, instead of a new line, might be useful to do a tab instead to separate the values with a tab. So let's execute the file. As we can see here, it appears that we have more than 9 elements in each row. That's because we forgot to skip a line. Let's do it. After each row, we need to print a new line. Let's try again. Correct. So now we have our Sudoku grid initialized with 0 values. The Sudoku grid can be generated using a lot of other algorithms. We will follow here a simple approach. We will go through each cell and we will pick a random number from 1 to 9, and then we will validate it inside the current row, the current column, and the current 3x3 subgrid. The program will try many times to generate the correct number until it finds the correct combination. So for this, we will try to create a new method. Let's call it generate. As we did for the other methods, we need to go through each cell and generate a correct number. Like this. Here we should put, instead of 0, we will generate a random number from 1 to the size. In this case, the size will be 9. Maybe then we do with it as we did for the other methods. It will be useful for us to return the instance of the game if we want to chain other methods. Let's use this function, uncomment in the generate, and let's see the behavior. As you can see here, each cell has a random number in it, but the cells are not valid. For example, 4 here shouldn't be in the same row since it's repeated. 3 is repeated in the same block, which is wrong. So let's start doing some validations. What we want to implement here is to validate the cell, and while the cell is not valid, we will keep generating a random number. So here we will create a new method that will try to tell us or return a boolean with whether the cell is valid or not. This method will accept the coordinates of the cell and return a boolean whether the cell is valid or not. For the cell to be valid, we need to check the 3 rules of the Sudoku game. We need to check if the cell is valid in the current row, is valid in the current column, as well as if it's valid in the current block, which is the subgrid, the 3x3 subgrid. In addition to these 3 rules, we know for sure that if a valid or a cell contains the value 0, it means that it's not valid by default. So let's add it to the conditions. Now we need to create the 3 validation methods. Is valid in row, is valid in column, and is valid in block. Let's return true for now, or maybe we can just copy paste it. So now we have the 3 methods. Let's start by implementing is valid in row. All of these methods need to receive the coordinates of the cell in question. Then in here we will need to loop through each cell in the same row, like this, and we want to skip the currently selected cell. So if the current value equals the current cell, we can just continue. So next we will check for each cell if the generated value exists already. So we will need to fix the current row like this, and the column will be the currently selected column. We will check against the currently selected cell. So if we find an existing value, we will return false in this case. So let's try to see the behavior now. We have an error. Is valid in row needs the correct argument to operate. So let's give the correct values, and we will do the same for the other functions at the same time. X and Y. Let's provide some visibility here by moving these to a new line like this. Let's try again. Alright, let's see if we have duplicates in the same row. It appears to be working fine. Probably this is a good use case for test-driven development. But for this simple example, we can continue like this, and let's implement the is valid in column instead. Maybe we can copy the same logic as it's very similar. The difference here is that we need to fix not the column or not the row, we need to fix the column instead. So we should use here the Y. And then if the current value is the X instead, then we can skip it. Now it should be working fine. Let's try again. And it appears to be stuck. So if you saw it coming, you are right. In some cases, when generating a valid grid, we get to a state where we cannot put any more numbers. Let's visualize this by slowing down the generation process and putting some sleep functions so we can see it clearly. So after we generate the number, let's try to render. And then let's try to sleep for, let's say, 500 milliseconds. Let's try again. If you look closely here, you can see the generation process reached this stage, and it will keep trying and filling the same or the cells until it finds the correct value. But sometimes it will stop and will not be possible to find a correct value. Let's see. So for this example, you can see that it got stuck here. Only values that we can accept in this row are 8 and 9. And it tries here to put 8, but it cannot be valid in this column. And if it tries to put 9, it will fail as well, since it exists already. So in this case, we should give it a limit of maximum attempts before we regenerate the full grid. Let's try that. Let's comment our render function and sleep function. Let's define a new constant. Let's call it maximum attempts. Let's start with a value of 100. Each time it will try to generate the number 100 times before it will skip and reinitialize the grid and try again. This number 100 can be adjusted as we go. Since the probability of a number being picked is 1 over 9, then we give it 10 times more that for it to pick all the numbers possible from 1 to 9. So let's continue. So this logic inside the generate method needs to be inside the do while statement. So we need to try it and retry it while it's not valid. So while statement is the perfect option for that. Let's say that we want to say while it's not is valid grid. It's a flag that we will follow. Let's format. Let's create it and initialize it to true. Each time we start, we will assume that the grid is valid. Say it's true. Then, each time we start, we need to initialize the grid again to start on a clean plate. Next, each time we try, we need to increase the grid generation attempts. First, we need to initialize it for each cell with a value of 0, like grid. Here we will keep track of how many times we try to fill that specific cell with the correct number. So if the number exceeds the maximum attempts of 100, this time we will consider it as impossible and we will move to the next grid. So if the grid generation attempts is more than the maximum attempts per grid, then we should set the flag to false and then break from the 3 loops. The first one is while, and the second one and the third one are the 2 for loops. So we will use break with an argument of 3 to break out of the 3 of them. Let's format. Let's try again. But this time we will render, but we will not sleep for the 500 milliseconds as it will take a lot of time. Let's see. So it got stuck because we did not increment the number of tries. Like this. Let's try again. There we go. So we shouldn't have duplicates in the rows nor in the columns, but we might find duplicates in the same block. So let's try to solve that. The next function to implement is invalid in block. In order to determine in which block the cell is located, we can follow a simple rule. For example, let's say we want to determine the block of this cell. Here we can divide x coordinates of this cell by 3 and then multiply it by the block size, and we will get 6. 6 is the start of the block, which means this one, and we will be looking for cells that are the start of the block plus 3, and the same we will do it for the columns as well. Let's try by defining the start or the block start row. Which will hold the result of the int division of the row or the x that we have now. Or just to make it clear, maybe we can put here the row and the column. Maybe we can change it in the others as well, just to keep it consistent. But we can start by the row, and we should divide it by the block size. And then, to get the start of the row, we must multiply it by the block size. Like this. This is for the row. Here it should be in division, div, and we can do the same for the column. So probably we can do like this, col, and here we can replace it as well with col, and it should be the same operation. Then instead of looping through the full grid, we will loop only on the subgrid. So we need to loop through starting from the block start row, and then we should only go to the block start row plus 3, which is the block size, and we can do the same for the column. Here we can replace this one with J. So instead of row, we will replace it by column. So as we did for the validation of the row and the column, we need to skip the currently selected cell, so the cell will not compare against itself. Then we should check if the value of the currently selected cell equals to the currently generated cell, which means that the value exists already in a block, so we need to return false then. So instead of I, we need ij, and we will put here the row against the row and the column. we return false, or else we will return true. So this will allow us to generate a fully valid cell. Let's try. There we go. Let's try to do some validation using our eyes. Although it's very good to implement test-driven development in this case. Let's see. It looks good to me. There are several enhancements that we can implement for this, but the basic functionality is there, and we can successfully generate valid grids that we can distribute and share with family to play. So thank you for watching.